Hello everyone, and welcome back to another Eng 130 video tutorial. And in this tutorial, it's going to be a little bit different. We're going to be covering midterm review questions. I know you guys have the midterm coming up. I know you're super excited. So let's go over some of the midterms and just make sure to keep you guys excited. I know when you first see these midterm questions, I know you're going to be a little bit freaked out because yes, they are a little bit challenging, but remember, the goal of the midterms is to challenge you. They're not going to be easy. It's not going to be like high school, but I know that you guys can easily solve them because you guys are smart students. And really, the secret to the midterm is just not freaking out. Usually a lot of students will look at this and go, that's a lot of words, that's a lot of angles, that's a lot of numbers. Just relax and everything will always be fine. Well, unless you fail, then it won't be fine. I'm just kidding around. You guys are all going to pass. So this question is really, really good because it covers all the concepts that you could see on the midterm coming up. Now, we already said that force reduction won't be on the midterm. And if you look at parts C and D, so these parts way down here, part C, part D, well, then you're going to wonder, well, is that force reduction? Because that's kind of what we get in force reduction. But in my opinion, those two questions, they're fair game. Because it's not really force reduction. Force reduction is turning forces into moments, stuff like that. This is finding the components of forces. So that's going to be fair game. So questions C and D on this midterm, very, very important. It involves something called the dot product, which, trust me, we know you guys all hate so much, which is usually why we like to include it on exams. It makes it challenging for you guys. But enough with the talking. How about we just start the example, do the first couple questions, see how you guys feel, and then we can discuss those harder ones later. So looking at the question, it says two forces, F1 and F2, are applied at point A opposed to OA. Okay, well, we see that in the figure. That's not too bad. It says force 1 has a magnitude of 100 newtons and is directed along line AB. Force 2 has a magnitude of 150 newtons and has the coordinate direction angles shown on the figure. Now, this is going to be very, very important. And this is why I like this question, because it covers 2 out of the 3 cases that you'll see for 3D forces. Remember, the first case is trigonometry. I doubt they'll give you trigonometry. They might, so be ready for it, but trigonometry is kind of a rare case because it doesn't really test your knowledge of 3D forces. It's just simple trig. So if we look at question A, it's probably the most straightforward one, and in my opinion, should probably be worth a little bit more marks because it's a lot more work than all the other questions, but it says determine the resultant force Fr, which is basically F1 plus F2. And then, of course, express Fr in Cartesian vector form. So not a very challenging problem, more a time-consuming problem. And these time-consuming ones are the worst because they usually involve a lot of calculations, and the calculations themselves are usually very, very simple. The problem students have, of course, is that you're freaking out. You're freaking out. You're trying to go fast. This is going to be the first thing that you see. You're going to be scared against the clock. You got 2 hours. So one of the problems is you guys are going to mess up that initial calculation. And it'll probably just be a simple one, a calculator error or something. And not because you guys don't know how to do it, but just because you guys are freaking out and trying to rush so fast. But here's the problem. If you look at question A, the whole goal is to determine Fr. Okay, well, let's say you get Fr wrong, and then you go to question B. Well, like if you look at FB, oops, I went to the wrong marker, back to highlighter. If you look at the question B, you need Fr. You look at question C, you need Fr. You look at question D, you need Fr. So it's one of those things that you should really try and get Fr right because it'll come back and haunt you in the later questions because you need to base your answers on it. So, of course, as you guys know, 2011 doesn't have a solution, I don't think. So these are my calculations. I'm hoping that they're right. But if I'm not, I'm sure I'll get a lot of emails telling me how dumb I am. But that's fine because it helps me correct. So if you guys see a problem, let me know. But let's get started. So there's 2 real cases that we can do right now. 2 cases. We have F1, and if we look at F1, it's kind of the coordinate point cases. We give you 2 coordinate points. From there, you can find the unit vector. We look at F2. Well, it's the second case where you're given coordinate direction angles, and with those, you can find the unit vector. And remember, the whole goal right now is to find the unit vector. And the reason why is because we need to find each one of those forces, so F1, in Cartesian vector notation like that. Well, how do we do that? Well, we know a force vector is going to be equal to the magnitude of the force vector. So this would be the magnitude of F1 which we're given in the question, times a unit vector multiplied by a unit vector. So if we can find the unit vector of those two forces, we can easily convert the forces into Cartesian vector notation and then add them up by just summing the components. So it's not bad. So for F1 though, we have to decide, well, how are we going to find that unit vector? And we decide, okay, well, we're going to use the coordinate points. It gives us a point at A, it gives us a point at B. We can use position vectors to find them. So now the question becomes, okay, well, do I go point B first or point A first? Which one? So if we look at this force, it goes from point A to point B. So this will be unit vector A, B. Because remember, it goes from A to B. So to find unit vector AB, so UAB, what we can do is we can take position vector AB and we can divide it by the magnitude of RAB. So that's a simple formula that I know a lot of you guys already know. It's kind of the only reason why we do position vectors is to try and find that unit vector, stuff like that. But now it becomes a question of, okay, well, I can find UAB if I have RAB. How do I find RAB? Well, that's actually the nice part, because RAB is just going to be equal to the coordinates of B, so the point at which you end up at minus the coordinates of A. And that's the initial point that you start at. So we can just look right at the diagram and say, okay, well, the coordinates of B are 6, 0, and 10. So that was already nice and easy. Didn't really have to do any work there. Just look at the diagram. Coordinates of A, well, they're also given. It's 0, 12, and 5. Well, doesn't get much simpler than that, because from here we can go right into the vector. So if we look at the I component, it's going to be 6 minus 0, which is going to be 6. The J component is 0 minus 12, so negative 12 in the J. And then finally we got 10 minus 5 for K, so it's going to be plus 5 in the K direction. But remember, since this is a position vector, it's going to have units. It's going to have units of distance. And if we look at the diagram, all of our points are given in meters, so we know this can have units of meters. So similarly, we can use this position vector to find the magnitude of the position vector. Because remember, that's kind of the other key. I'll highlight, I'll put a purple arrow. That's the other key to finding the unit vectors. We also have to find the magnitude. But you guys already know the formula for that too, because in 3-dimensional vectors, it never changes. And actually in 2-dimensional vectors, it also never changes. So the magnitude of RAB, well, we know that that's just going to be equal to the square root of all the components squared and added together. So we're going to go 6 squared plus 12 squared plus 5 squared. And we know that's going to give us the magnitude. So I'm just going to end this. When you type all that in, I get 14.32 meters. So remember, this will also have units of meters. It's a length. And what is that length? Well, that is the actual distance between point A and B. So if I take a tape measure at B, run all the way to A, this is what the tape measure is going to tell me, 14.32 meters. So to find the unit vector, all we're going to have to do is look at the formula above, and it says that we're just going to take the position vector and divide it all by 14.32. So I'm going to go to the I, the J, and the K components and divide each one of those values by 14.32. And when I do that, I get that the unit vector is going to be equal to 0.419. Remember, this is a vector, so it's going to have an I component. And then minus 0.838J. And then finally, we're going to have plus 0.349. And that'll be in the K direction. And when we divide the position vector by the magnitude, what we're doing is taking something of meters, dividing it by meters, the units cancel out, the unit vector will have no units. And all I have to do to get the force vector is just, if we look up, we're just taking that magnitude, and if we look up here, we go the magnitude of F1, it's given right in the question, right here, as 100 newtons. So we know this is already 100 newtons. All we have to do is multiply each one of those components by the magnitude, which in this case is 100 newtons. So what we're going to do is we're going to get a force vector of 41.9 I minus 83.8. And that's in the j, and then plus 34.9 in the k. And remember, since we multiplied everything in that vector by something that is units of newtons, this will now have units of newtons. So that's the first case. That's going to be how you solve for f1 in Cartesian vector notation, or any f in Cartesian vector notation if you know 2 points. Now, what's nice is this is actually the harder of the two cases, and it's not even that hard. It's one of those things that once you know the principles, you just kind of go through the same procedure every time. So the second one that we have is going to be the coordinate direction angles. So coordinate direction angles. Coordinate, oh my gosh, I hate writing so much. Oh, I was going to put diagrams. I'm sorry guys, my mind is not here right now. I'm just going to put coordinate angles. You guys will have to do without the direction for now. So what we find is that a unit vector can be obtained if we know these coordinate direction angles. So what the unit vector will be is cosine alpha in the I plus cosine beta in the j, and then plus cosine gamma, and this one will be in the k direction. So all we have to do is find those 3 angles. If we look at the diagram, it gave us a bunch of angles, so we should be able to figure them out pretty easily. So here's the trick to these. These angles are always based from the positive axis. I'm going to repeat that again so you guys really know. The positive axis. For example, let's look at gamma. That has to do with the z-axis. Oops, I went to eraser. If I look at this 45, it makes an angle with the positive z-axis. So I know that gamma is equal to 45 degrees. I look at beta now, so from the y-axis, we see that it's 120 degrees. And again, it's from the positive y-axis. So beta is going to be 120 degrees. But if we look at alpha, so they gave us one more angle and it's right here, it comes down here, which is the negative x-axis. So that's 60 degrees. That's not what we want to use. That's the wrong value. We always take it from the positive axis. So what this will be for alpha is that 180 degrees minus the 60 degrees. We have to shift the angle so it touches the positive axis. And that right there will get a lot of students. And that's very bad. Want to try and avoid that. But since we know the angles, we know the formula, we know that the unit vector, and it doesn't go from point to point, so I'm just going to put 2, because it has to do with force number 2, is equal to negative 0.5i minus 0.5 in the j, and those values just come from cosining 120 degrees, and then plus 0.707 in the k. Remember, unit vectors, they don't have any units. And in a similar procedure, I can find f2 by just multiplying all the unit vector by the magnitude of f2, which is 150 kilonewtons, or not kilonewtons. When you get into structural design, you're always going to think of kilonewtons because newtons are nothing. You always have to deal with people and the weight of concrete, stuff like that. Your mind just gets lost in it. But what we get is negative 75i minus 75j, and then plus 106.1, and that'll be in the k. And the bracket, remember, this will have units of newtons, so not kilonewtons, newtons. If you guys see kilonewtons, please just ignore it. My head is always in structural design, so I get lost sometimes. All right, so this is the hard part of the question, finding those 2 forces in Cartesian vector notation. Because once we have them, we can say that the resultant force is just going to be F1 plus F2. So if I take those 2 forces, I can find that FR is equal to, and then brackets, I'm just going to add the components of each one. So for the I, what I would do is I'd take 41, I'll go in pink. I'm going to take the I component of F1, so 41.9. I'm going to add the I component of F2, so minus 75. And what I get is negative 33.1i, and then minus 158.8 in the j, and plus 141k. And it's all units of newtons. So I'm just going to highlight this because remember, this was what the question wanted. It wanted FR. Oops, that was terrible. It wanted FR in Cartesian vector notation, which is what we have right here. I don't know how much I can extend that past. So if we were to look at where the components come from, like the negative 158.8, what we see is we're going to take the j component of f1, which is negative 83.8, negative 83.8, and then we're going to add on the j component of f2, which is negative 75. You add those together, you get negative 158.8. So that's question A, part A. So that seems like a lot of work for 3 marks, and trust me, it is. If you guys look at the next questions coming up, they're worth pretty much the same amount of marks, except they're actually a lot shorter. So I'm just going to put part B right here. Now let's go up and take a little peek. So what part B would like us to do is find the angle. So of course you're going to get an angle. Like that's a given. If you guys think that you're going to get away with not finding an angle in this midterm, you guys are crazy. You're going to have to find an angle. So we want it between post OA and the line of action of the resultant force, FR. So if we look at angles, we have basically OA. So we're going to have a vector that comes out like this. So we want this direction, and then we want it against the force vector, which we see comes out, or that's F1. So then we have a force vector FR, which pretend comes out like this. Who knows where it comes out? And what we're going to want to do is find the angle between these vectors, theta. Okay, well, we actually know that there's a nice equation where it's cosine of alpha, or cosine of theta, so this is the angle that we want, is equal to the dot product of our 2 vectors. So we're going to have FR as one of the vectors, and then we're going to have to divide that by the magnitude of both vectors. So we're going to need FR, the magnitude, and times the magnitude of a second vector. And this is where you guys are going to have to wonder, okay, well, what can I do? So there's actually a couple things you can do, and they're both going to equal the same. So all we need is a vector that goes in that direction. It doesn't matter if it's a force vector, a moment vector, a position vector, a unit vector, because they all have the same direction. So if we look at here, there's 2 things we can do. We can find the position vector ROA, and then, of course, we're going to need the magnitude of ROA. Or what you can do, and it's actually going to be the same amount of work, is you can find the unit vector OA. So to find that, you need the position vector ROA, and you're going to have to divide it. So it's actually the same amount of work. So what I'm going to do is I'm going to do the unit vector OA, because we know that the magnitude of unit vector OA is equal to 1, because it's a unit vector. So effectively, this is equal to 1. I can kind of get rid of it in my equation. But remember, you're not saving yourself any work, because if you're to do the position vector, you're still going to need to calculate the magnitude anyway. So not saving yourself work, it's just what I'm going to do. So we need ROA, which is going to be equal to the coordinates of A minus the coordinates of O. And what's really nice, the coordinates of O are 0, 0, 0. So this is like taking something and subtracting 0. So we know that this end part right here, well, that's just going to go away. And what we're left with is just a nice vector, which is equal to the coordinates of A. And if we look up here, there's 0, 12, and 5. So we're going to have 0i plus 12j plus 5k. And the brackets, and this will have units of meters. We can also find the magnitude of ROA. And I'm going to erase one of the lines because that is super diagonal. And we know it's equal to the square root of all the components squared. So it's going to be 12 squared plus 5 squared. And that's a very, very common one. You guys will see that a lot, because 12 squared plus 5 squared and then square root, it's actually equal to 13. It's like when they give you the 3, 4, and 5. This is another way, because it's a nice easy number, makes it really easy for us to grade. So to find the unit vector ROA, we're just going to take all of the components in ROA and divide them by 13. So 0 divided by 13, well, that's going to be 0i. If we go 12 divided by 13, what we get is 0.9, so plus 0.923. That's in the j. And finally, the last one's going to be 5 divided by 13, which is 0.835, or sorry, 385. And that'll be in the k direction. And this will be a unit vector, so they have no units. All right, well, now that I got my unit vector, I can just throw all that stuff into my dot product to start getting cosine of theta. So if I were to go FR dot UOA, what that would be equal to is all the components multiplied by each other. And I'm just going to go down a little bit so I got room. So it's going to be all the components multiplied by each other and added up. So if I look at FR in the I get negative 33.1. And if I look at U, the unit vector in the I, it's 0. Okay, well that's easy. We know that's going to be 0. Look at the J component, negative 158.8. 158.8 times by the J component for U, which is 0.923. All right, so now we just move on to the last one. So we look at the J component for the force, we got 141. And then the J component for the unit vector, 0.385. So if you throw all that in, what you get is a value of, what do you get? Negative 92.3. Okay, so now that we know that cosine of theta is equal to negative 92.3, and it's divided by the magnitude of FR. Well, we actually haven't calculated that yet, but remember, finding the magnitude is something that's very easy because we're just going to take all those components, square them, add it together. So we look at FR, the first one's 33.1, so 33.1 squared plus 158.8 squared plus 141 squared. So it's just like something you can do to just maybe save yourself a little bit of time. Remember, I'm pretty thorough when I go through these examples, and it's not because we expect this much work from you guys. It's purely just me hoping that you guys understand everything. So if we look at the right-hand side, we see that that's actually just a scalar value. It's negative 93.3 divided by a number is equal to cosine of theta. So you guys can easily solve, and when you do, you should get theta is equal to 115 degrees. And that is it. So we can put a nice box around that. And that's it. So we can move on to the next part, which is part C. And by this point, you're thinking, Clayton, you just did a ton of work for 5 marks. The question's not even halfway done. Not even halfway done. And here's what I can kind of say to that, and it's going to sound a little funny. A lot of these marks aren't based on the length of the question. Parts A and B, they were long. They were kind of tedious. But most of those marks, well, you don't get a lot of marks. And the reason why, well, it's tedious, but it's easy. Simple calculations. If we look at part C and D now, they're worth the same amount of marks as part A and B, but it's going to take less than half the work. And the reason why that is because these ones are tougher questions. These ones really have to get you guys thinking. And let's find out how you do it. So part C says determine the component of FR. So right away you're thinking component, oh, that's garbage, that's crap. Components suck. And in the direction from point O to A, and express this component in Cartesian vector form. So here's my little hint to you guys. If it ever asks for the component of something, the component of something on a line, the component of a force on a line, the component of a moment on a line, your head should scream dot product. Because the component of a force on a line, so in this case, the component that we get, FR, which I like to call parallel on a line, is going to be equal to FR, so whatever you're trying to find the component of, dot with the unit vector of the direction you want to dot it with. And this is when you're going to start realizing, oh, this question gets really easy. Because look what we have here. I'm going to highlight it in purple. FR dot UA. And if we look up here, what do we have here? FR dot UA. So if you already did the last part correctly, oops, if you look down here, you already have it. So we know that FR dot UA is equal to negative 92.3 newtons. So there's actually very, very little work to do with this, but this is what's going to stump a lot of you guys. And I'm going to draw a picture to hopefully help, and this will help with part D too. So let's say that we have our FR. Okay, so this is FR, and it's a vector. Basically what we're doing is we're taking this and we're taking this line. So this line right here is OA. And what we just did is project FR onto OA. So if I were to come down here, and make a 90-degree angle, so this is 90 degrees, this distance that I just found right here, this is going to be equal to the negative 92.3. And the only reason why it's like that, of course, is because his vector is going in the opposite direction. It's actually not lining up like this. I'm just trying to show you guys with a triangle. So what we just found is the magnitude of that component. We found the magnitude of that component. But the question specifically asks us to find the component in Cartesian vector form. So it comes back to, okay, well, you guys have to remember that to find a Cartesian vector, so in this case we want that FR parallel, well, that's equal to the magnitude of FR parallel, which we now have. And then remember, to find a vector, we always multiply it with a unit vector. Okay, well, what unit vector do we use? Well, we got to think about this. FR parallel, that's going to be in the exact same direction as OA. So this right here, this is going to be the FR parallel. So therefore, if it's going in on the line OA, the unit vector has to be OA. So all we're going to have to do is take that and multiply it into OA, and what we're going to get is this. So we're going to take the negative 92.3, multiply it by the first component of the unit vector, which is 0. So we're going to have 0i negative 92.3 times the j component, which is 0.923. We get negative 85.2. And that's in the j. And then finally, we're going to take that magnitude, multiply it by the k component, which is 0.385, and we get negative 35.5. And that'll be in the k direction. We can end the squiggle brackets and put our units of newtons. So since this is a final answer, I should probably put FR parallel out in front so everybody can see exactly what it is. And I put a nice box around it. That is not a box, that is whatever shape that is. I'm not good at trig. And that's not much better, but I can move that one. Perfect. So now we just found FR parallel. So if we look at this question, it's basically a two-liner, and that's worth 2 marks. And now what you guys are going to realize in the next question is the work doesn't get much harder. It's just about knowing your concepts. So if we look up here, the last part of the question, part D, says find the component of FR in the direction perpendicular. So we just found the parallel direction. Now we need to find the perpendicular portion to post OA. And again, express this component in Cartesian vector form, which is going to be fine because, as you guys will realize, it'll already be in Cartesian vector form. This question is actually easier than the last question. So it comes back to this triangle. The key thing about this triangle that I told you guys, now which I'll do dark green, is that the angle between FR parallel and the axis was 90 degrees. I kind of drew it there in red. So if that's 90 degrees, FR perpendicular must just go up like this. Something like this. And then it makes you wonder, okay, well, actually, if I were to do resultant forces, stuff like that, we know that FR is going to be equal to FR parallel. So we know those two already, but it's going to be plus FR perpendicular. And that makes sense because if I wanted to get from point, let's just call this point X to point Y, I have 2 options. I can just go all the way up FR and end up here, or I can go FR parallel to get to here, and then I go up FR perpendicular. I end up at the same point. They're equal, and this formula is always true. So to find FR perpendicular, all you have to do is rearrange the formula. Well, that's easy. FR perpendicular is going to be equal to FR minus FR parallel. And we know both of those values, and they're both already in Cartesian vector notation. So all you're going to have to do is just do some vector subtraction. And then when you do that, you'll get that FR parallel is equal to, so it's going to be FR minus FR parallel. So if we go up to the top, our I component of FR is the negative 33.1, and we're going to be subtracting 0. So the first component, well, it's going to be negative 33.1. And that's in the I direction. The second one, we're going to look at the J, which is the negative 158.8. And we're going to be subtracting negative 85.2. So what do we get there? Well, we get minus 73.6 in the J. All right, perfect. Well, now the last component, we got 141. We're going to subtract negative 35.5. So what we get is a plus 176.5. That's in the K direction. We get in this bracket and put our units of newtons. So that's it. So those last 5 points were actually really fast, because let's be honest, these questions, the dot product, I don't understand. Oh, that's not going to work. I should get marks for every time I get a box off. All right, that works out fine. So it's funny because if you look at part C, it's not a lot of work, and that was half the question. But here's the thing, I don't know why. I'm actually kind of curious, but whenever we say dot product to you guys freak out. That's why we put it on all the exams, because we know it's like a guarantee getcha question. But dot product's really easy. You just take whatever force you want, and then you want to take whatever axis you want to project it on, just dot them together. You got the component. To find the perpendicular component, well, if you have the parallel, you just have to minus that from the resultant. You're good to go. So that's really it, guys. So this is the first question. If you guys will look, I already have the rest of 2011 on and all of 2013. I do not have question 4 for both of them, because remember, those will not be on the exam. If I threw them on as a lecture video, I know all of you guys would be sending me questions saying, will this be on the exam? Will this? No, it's not going to be on the exam, so I didn't cover it. You guys won't need to know it. This is what you'll need to know. Because again, I promise you, I'm not even giving stuff away. I just know it's always on every midterm. Angles, dot product, because it always gets you. So make sure you guys know how to do that. So thank you all so much for listening. If you see a mistake, please message me. I don't think that there is. I really don't think that there is, but if there is, you never know. I'm pretty dumb. So yes, thank you guys all so much for listening, and I'll see you guys in the midterm. All right, thanks guys.